when we look at an inclined plane or a problem done on an inclined plane, it changes things up a little bit. So far we learnt on a horizontal surface that your force of gravity and your normal force kind of cancel one another out. That's why you're not sinking into the floor. Okay, because that normal force cancels, it's in the opposite direction of gravity. But the rules for normal force are that it is perpendicular to the surface. And in this case, the surface is inclined, so the normal force is going to be perpendicular to the incline, not to the horizontal. The force of gravity, however, is always pointing straight down. So these forces on an inclined plane do not cancel out with one another. All right? So we've got force of friction going parallel to the horizontal and opposing forward motion. All right? Now, these are the actual forces that are at play here in this object. But if we were to add these up, if we want to look at what is impacting this in the y or what is impacting this in the x, we can't necessarily do that when the image is as such. We've got to actually draw in our y and our x component for a force of gravity. Because the y and the x component for the force of gravity will follow our vertical and our horizontal that we've decided. They'll either be perpendicular to the incline or parallel to the incline. And that's where we're going to see that certain things can cancel one another out. So in this case, FGY starts at the tail of the force of gravity, of its vector, and it points perpendicular to the incline straight down. Okay? In this case, we're also going to have an x component for gravity. And the x component is going to leave the tip of the FGY and it's going to go towards the actual tip of FG. So it is going to be parallel to the actual incline and it is going to run to the end of the FG arrow. So this is FGX. Okay? So if I want to actually write all of my x players or forces in the x, I have two forces in the x in this image. I've got the x component of gravity and I've got my force of friction. If I want to look at all the players in the y, I've got my normal force and my y component for my force of gravity. So we don't ever really look at FG as a whole when we're doing an inclined plane problem. We break it down into its x and its y. Now, if we are playing with regular geometry here, okay, we know that this angle right here, this angle in this little triangle, is going to be the same theta as the theta of our incline. All right? They turn out to be the exact same angle. So here's where figuring out what the x and y components differ a little from regular vectors. We remember that finding the x and y component for vectors, those formulas are up at the top of the screen. To find the x and y, the FGX and the FGY in an inclined plane problem, we use regular trigonometry. All right? And you're going to see that it actually changes the x formula and changes the y formula. Because FGY in this case is the adjacent over the hypotenuse, to find FGY, you are going to use the cos of the angle. All right? So FGY is the same thing as saying, and I'm actually just going to erase this here, FGY is the exact same thing as saying, in order to find your FGY of this small little triangle, all right, that's adjacent to the angle, and you know your hypotenuse. You've been given the mass of the object. So you know the force of gravity, which means you know its mass, and you know what gravitational acceleration is. So FGY here is the same thing as saying the mass of the object times gravity times the cos of the angle. All right, and that's simple trig because it's the adjacent over the hypotenuse. Whereas for the actual x of that triangle, that FGX, you're looking at FGX being the opposite. FGX is going to be opposite over hypotenuse, right? Because your x is down here and your angle is up here. So it's going to be mass times the gravitational acceleration times the sine of theta. It is the opposite to when you're trying to find your x and y components. Because remember, when you're trying to find your x and y components, for x component, you're using cos theta. For y component, you're using sine theta. However, on an inclined plane, and this is the only time you use this, on an inclined plane, to find your FGY, you are going to use cos. And to find your FGX, you are going to use sine because of trigonometry.